Hey, in this video, we're going to learn how to do stoichiometry calculations. That's why I called this Stoich 1. And we already had a bit of an introduction to this in my class. We had a lab where we reacted baking soda and vinegar, and we put those together and we got all three of these products, and we did a big calculation. And in the lab, we used this big giant table to do that calculation. And it was pretty scary, and it looked pretty complicated. So my goal in this video is to give you a way to do the calculation that's a lot simpler and a lot more compact in your notebook. Okay. So a couple things we learned in that lab. Number one, when we did this reaction, there was baking soda and there was acetic acid. That's the active ingredient in vinegar. And when we were done, there was some baking soda left over. We learned that when a reactant is left over, when it's not totally used up, that's called the excess reactant. And the one that is totally used up, that was the acetic acid, that's called the limiting reactant. Okay. Another thing we found out, and this is what we found out from the calculation, is if you know how much reactant you started with, right? If we know the masses of the baking soda and vinegar to start, then we can calculate how much carbon dioxide this reaction is going to produce. And that was an important number for this lab because carbon dioxide is a gas, and when we did the mass of all these products at the end, it didn't match the total mass that we started with. So we used that calculation to determine, oh, wait a second, that's where the missing mass is. We calculated how much carbon dioxide this reaction produced. And that's what stoichiometry allows us to do. We can calculate amounts. If you know how much you start with, you can calculate how much it's going to produce of any of the products. We were just interested in that one last time. So here's what that looks like. I'm going to show you the full calculation for the way we're going to do it to determine how much carbon dioxide this reaction produces. And here it is. So there's the question, how much CO2 will this reaction produce? And this looks pretty big and scary, doesn't it? Okay. In fact, some of you might think, well, this doesn't look any better than the chart. Well, once we work through this, I think you'll find this is not a big deal. It's a lot to write down, but most of it is just units and formula names to keep track of things. The numbers part of it is really quite simple. So first, a couple of vocab things, okay? What you start with in these calculations, that's what's given to you. 1.5 grams acetic acid. That number I took from our lab yesterday. You had about 1.50 grams of acetic acid in your beaker when you started the reaction. And I chose that number instead of the baking soda because that's the limiting reactant. You always want to choose the amount of the limiting reactant because the limiting reactant determines how far the reaction's going to go. After that one's used up, it stops. Okay, so you're given that number. That's the limiting. Then you got three terms in parentheses here. Two of these terms have moles on one side and grams on the other. This one has moles on top, grams on the bottom of the same chemical. This other one has grams on top and moles on the bottom. What we're doing is we're converting from moles to grams or from grams to moles. Okay, so those are called conversion factors. These allow us to convert from grams to moles or back. So in this calculation, we're starting with grams of acetic acid, and then we're converting to moles of acetic acid because that's what we need to know. And then in the middle, you'll see it's moles over moles, but it's two different chemicals, right? I have moles carbon dioxide on top and moles acetic acid on the bottom. So in this one, this is the term that allows us to switch from acetic acid to carbon dioxide. I'm starting with how much acetic acid, and I'm trying to find out how much carbon dioxide. That middle term is where that switch happens. And the vocab word for that is mole ratio. Okay, it's called a mole ratio because a ratio is just a fraction, and that's what we have here. We have moles over moles in a fraction. It's a mole fraction, a mole ratio. So that's the vocab. How do we deal with this thing? Well, it's actually quite simple on the calculator, okay? You multiply the tops and you divide the bottoms. And you can do it all at once on your calculator. So that's what I'm going to show you next, okay? I've got a bunch of numbers on the tops. Now we'll start with the 1.5. That's on top, okay? If there's nothing underneath it, that's on top. So I'm going to go 1.5. Then I'm going to go across the tops. The next one is a 1, so I can go times 1. The next top over here, 1 mole CO2, that's another 1, so I'll go times 1. And then finally the last term on top is 44.01, and since it's on top, I'm going to multiply 44.01. Then I go back to the beginning and I'm going to look at the bottoms. 60.06, that's on bottom, so I'm going to divide by 60.06. The next two are 1s. Well, I can divide by 1. Now some of you smarty pantses know that if you multiply or divide by 1, it does nothing. So we really didn't have to even do the 1s at all. We only needed the 1.5, the 44.01, and the 60.06. And my final answer here is 1.099. I'm going to round that up to 1.10. I'm keeping 2 decimal places. So again, what we did was 1.5. We took that times 44.01, and then we divided by 60.06, and that equaled 1.10. And that's it. That's all we had to do. So this thing is really big and ugly looking when I write it all out. Well, big and beautiful, pardon me. But when you actually write down what you're doing on the calculator, you're just multiplying and dividing 3 numbers. It's no big deal, right? And that's our final answer, 1.10 grams CO2. Boom. Stoichiometry isn't so hard after all, right? We just calculated how many grams of CO2 this reaction will produce. One last thing you need to know about units. How did I know the final units were grams CO2? Well, there's this thing in algebra called cancellation, okay? Whenever you have a unit on top, whenever you have anything on top, and then it's also on the bottom in a big problem like this, they cancel. So here I have grams acetic acid on top, and I also have grams acetic acid on the bottom. So those units disappear, they cancel, the numbers stay, don't cross those out. Then in the next term I have moles acetic acid on top, right here, and then I have moles acetic acid on bottom, right there. Those are going to cancel. Last term, I've got moles CO2 on top and moles CO2 on bottom here. Those cancel. And that leaves me with only 1 unit left in the problem, right? I've got grams CO2 right there. That's the only unit I have left once I'm done canceling. And that was the unit I used as my final answer. And that just makes sense. Kind of nice. You'll notice as well that I left the numbers, and I have the 3 numbers left over that did not cancel out. So you take those 3 numbers, you take these units, and that just gives you the answer that you need. So that's how I did those units, okay? And this is basically it, okay? I'm going to, of course, as we move on with our video lessons in the next one, I'll take some of the training wheels off and I'll let you learn how to set these up yourself. But this is the basic idea right here, okay? Now what I'm going to do right now is I'm going to take off one of those training wheels and I'm going to rewrite this example. And we're asking the same question, okay? And I just want to teach you where I got some of these terms, right? Like, how did I know what to write for the conversion factor? How did I know what to write for the mole ratio, okay? The first thing is always given to us. We have to get that from our experiment, right? We started with 1.5 grams acetic acid. And then you always have a conversion factor next. Now what the conversion factor does is it converts from moles to from grams to moles. So we put 1 mole HC2, sorry, screwed up my formula here. And then the number that I got on the bottom, that comes from the periodic table. Okay? This number right here, how many grams of acetic acid are there in 1 mole of acetic acid? Well, that's a molar mass. How many grams are in a mole? That's a molar mass, the periodic table mass. Okay? So if you're doing these problems on your own, you need to go to the periodic table to get that mass. Then there's going to be the mole ratio in the middle. And then I'm going to skip over that for right now, and I'm going to just write down the conversion factor for CO2. And again, this conversion factor is saying how many grams of CO2 are there in 1 mole. Whenever you need to know how many grams there are in a mole, you go to the periodic table. Okay, so those two numbers come from the periodic table. The mole ratio, where do I get the numbers from those? I had 1s in there. If we look back up here, I had a 1 over 1. How did I come up with those numbers? I will tell you that sometimes they're not that same number. But first I'll put the units in. And these numbers come from the balanced equation. Okay, this and this. From the balanced chemical equation. Now we actually have that up above in our notes. It's right here. Okay, this is the balanced chemical equation hiding on top. And if you remember from our previous unit, we learned how to balance these. We put these empty blanks in front of each chemical, and we figured out what number goes in front, which coefficient, so that it's balanced. And this one happens to be already balanced. So that means that secretly, we didn't write them down, but all the numbers in front of each chemical are the number 1. And the ones we're interested in is this one right here, the number 1 in front of acetic acid, because you can see right here we've got moles acetic acid, so I go get that one. And then I'm also interested in the coefficient in front of CO2 from the equation. And if you look back on the chemical equation, you can see right here that the coefficient is also a 1. So that's where I got those numbers. Pretty cool. 1, 1. And then the periodic table mass for acetic acid, you got to go get some scratch paper, right? You got to add it all up. Hydrogen plus 2 carbons plus 3 hydrogens plus 2 oxygens. You got to do some work to get that number. And when we did that, when I did that, the number came out as 60.06. I did the same thing for CO2. I took a carbon plus 2 oxygens, and I got 44.01 from the periodic table, and that's what I put there. Okay, that's how you set these up. So I'm going to do one more example with those parts left empty, and then that's pretty much it. If you can do that, then you've got this. So what I'm going to do this time is, how about we do the synthesis of magnesium oxide. This is a pretty simple reaction, but this one doesn't have all 1s when we balance it. A couple of my chemicals have a coefficient of 2 in front of it on this one. So I'm going to say if we start with 8 grams magnesium, right, how much MgO will be produced? So we're going to follow that pattern that we had above. Okay. Here's the pattern. You start with your given number. You got a conversion factor, a mole ratio, and another conversion factor. For now, you don't have to memorize that. It's going to take a lot of practice before you get all this memorized. So I'm going to give you all that stuff right now. So the given number to start with is 8 grams mg. Conversion factor, 1 mole mg over how many grams mg. So what I want you to do now is pause the video. I want you to go find this number. And remember, that's the periodic table mass. Periodic table mass of what? Periodic table mass of magnesium. Okay, go pause the video. Go find that number. Ready, go. Okay, so you've paused the video. You went to find magnesium and found out that it's 24.31. If you didn't pause the video, shame on you. You need to actually practice, okay? Next comes the mole ratio. How many moles of MgO per how many moles Mg? And as I said above, these numbers come from the balanced equation. Well, I gave you the balanced equation. Okay, so this one I will do for you. This is the coefficient on Mg in the equation. Mg is right here in the equation, and it has a coefficient of 2. So I write a 2 right there. I want you to pause the video right now and go find the coefficient from the equation for MgO. Ready, go. Okay, so you looked up here, you've unpaused the video, and you found MgO is right here, and the coefficient in front of it is a 2. So you put a 2 right there. Great, that's the mole ratio. Final step is the conversion factor to grams of MgO. And remember, the conversion factors come from the periodic table. So again, this is a periodic table mass here. Your clues that it's grams. We always go to the periodic table for those grams. Pause the video right now. Go to the periodic table. Add up the masses for Mg and O. Write your answer in right here. Ready, go. Okay, you went to the periodic table. You've unpaused the video now. You found 24.31 plus 16 is 40.31. And that is our final bit of setup. Now you get to do the final step, which is, a reminder, multiply the tops, divide the bottoms. I'm going to highlight these just to show you. We have 8 on the top. We have a 2 on the top. We have 40.31 on the top. Notice I skipped the number 1. Multiplying by 1 does nothing, so you can skip over those. On the bottom, we have 24.31 on the bottom. Ooh, that's a bad highlighter color, huh? Let's go with green. 24.31 on the bottom and a 2 on the bottom. There's a 1 over here, but I can skip that because dividing by 1 does nothing. So I've highlighted the tops in yellow. You're going to multiply all those. The greens are in, the dividing ones on the bottom are in green. You're going to divide by those. Pause the video and do that, please. Ready, go. So you've probably unpaused by now, and you can see me, there we go, struggling to get my calculator working here. 8 times 2 times 40.31 divided by 24.31 divided by 2 equals 13.27. I rounded off to 2 decimal places. 13.27. And we were trying to figure out how much magnesium oxide is produced. Remember, these are going to cancel. Grams magnesium cancels grams magnesium. Moles magnesium cancels moles magnesium. Moles MgO cancels moles MgO, and we're left with grams MgO as our final unit. So that's what I write here, and that is our answer. Yes, there are a few steps, but each step is manageable. I hope this makes sense. Happy practicing.